So my name's Beth. I am going to give you a slideshow that you should be able to see on your screen, and every once in a while we'll zip over to one of the web resources that I'm trying to show you today. So I think that's pretty much it. We'll go ahead and get started, see if this works. So here we go. You guys see, get this. Click in the slideshow and then off we go. All right, technology. So yes, I'm at a technology facility here. So today's goal is to share STEM resources with you and give you resources that you can actually share with the kids and have fun with. So the three areas, I'm going to give you introductions on who we are, where we are, what the resources are that you're going to use. And then we will go to the web, which is where you're going to get most of your stuff and which is where I get most of my stuff. And we have the NICE network, which is all open use, which is fantastic. And we have MyScope outreach, where you can let kids work an electron microscope for free online. And then we'll end with talking about what we do here at the Cornell at the NanoScale facility. And I've helped Alexa in the past with career development days. And then I'm a big fan of showing kids things. So I have a few other things that we can offer. Okay, so my name's Beth. I am originally I'm a PhD microbiologist, but I have this passion for sharing science. And so I carved out a little niche in my job of being the youth outreach coordinator, which means anytime there's a field trip or anytime an elementary school wants me to come, I will do it. And I also do family events at the Ithaca Science Center and other area venues. So what is the CNF? So CNF stands for Cornell NanoScale Science and Technology Facility. And the reason that we're in outreach is it's not our primary goal, but it's one of our missions because the National Science Foundation funds us. So we usually show scientists and college students what nanoscale science is as part of our funding mission, but we've extended it to serving youth, especially in 4-H. It's one of our focus areas. So the NanoScale facility itself, it runs the entire length of the building that I'm talking to you in the basement, and it is a clean room facility like you would see in Silicon Valley in California, where people make very small things. And it has to be in a clean room where you see this person in this clean room suit, and mostly that's because they're, the particles of dust and hair that are covering clothes are bigger than these things that people are making. So we work on very tiny things. Any questions so far? This is really weird talking to a camera. Usually I have people asking questions. All right.
No questions yet, but it sounds exciting so far.
Okay, great. So the first thing that I tell people that I'm explaining things to or to the kids is what is nano. So nano is simply a prefix. It's like micro, milli, femto. And nano means 1/billionth. So when you put nano in front of a meter stick, you're saying that you're working in nanometers, which is 1 billion nanometers on a meter stick. And so it's very, 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 very small. It's inconceivably small. So I use a lot of pictures to show what we mean. And one of these, I'm going to zoom in because I see that it's not really that good quality. Dave just showed me how to zoom in on my slide. Dave, you're the best. Here we go. So on a slide scale, if I go up and down, okay. So the macro scale is what you can see with your eyeball. So humans and ants, you can see. We work down here in the nanoscale where we are actually making things that are the same size as viruses, as DNA. We'll also work in the micro scale, which is millionths of meters, where things that are the same size as one of your red blood cells. And so we have the technology to make things in that size range. And so we have to show people what that is first. So we usually show kids pictures like this. This picture is available on the resources that I'm going to show you later on. I zoom back out, it worked. So nanoscale science. Anything that works in the nanoscale is nanoscale science. And so people will make computer chips, optic light guides, all sorts of technologically advanced things to study and they come to our clean room to do it. Another example of the pictures that you can use to get across is just like this one. It's taken right out of a slide from NISENet, and it shows this is exactly what the kids can see. They'll see that nano means small. It translates it to something that they can relate to themselves. And then we will tell them that we make things that are very small, like the size of the drop of their blood, and go even 1,000 times smaller. And typically most kids know what DNA is because they have fun doing DNA extraction and all of that kind of stuff. So you have really good idea, or you have really good resources to show this. The other thing that I use are videos. The NICE network, which we will talk about shortly, has 380 videos on this Vimeo channel that I will give you. And you can basically see, you can introduce it in a really fun way. So you don't have to create anything, you can use what they have. And so I want to show you this example of I think it's a 3 to 5 minute video. And I used this on Tuesday when a high school group came by for a field trip. And it was pretty good. So let's see, I have to escape. I have to go down here. So this is on the Vimeo channel, tons of stuff. This is the NICE network Vimeo channel. And I've pulled up the intro to Nano video, 3 minutes. And here we go. We'll even maximize it.
What's the big deal about nanotechnology? Could it lead to a cure for cancer? How about making cheaper and cleaner energy? Or even shirts that don't stain? It's all about being itsy bitsy, teeny weeny, super duper small. Nanotechnology uses particles that are nanometers across, the size of atoms and molecules. A meter is made up of 1 billion nanometers. Imagine comparing this meter stick to a super tiny nanometer is like comparing the width of the entire Earth to the width of this marble. Your fingernails grow 1 nanometer every second. At the nanoscale, some materials, like gold, stop acting normal and start exhibiting unexpected properties. Stop acting normal and start exhibiting unexpected properties. Unexpected properties. If you cut a gold brick in half, both halves still look gold and shiny. Cut smaller and smaller, it still looks gold and shiny. That is, until you get small enough to be at the nanoscale. What's weird is that particles of gold 50 nanometers across, like the ones in this liquid, look green. Even smaller particles look red. That's because at the nanoscale, even small changes in size can lead to unexpected properties. And color isn't the only way that things act weird. All kinds of physical and chemical properties can change at the nanoscale. So why should you care? Doctors are working on ways to use nanoparticles to target and kill cancer cells without the horrible side effects of chemotherapy or radiation. By working on the nanoscale, scientists are making solar power and other kinds of renewable energy way more efficient and cheaper.
Nano-based water filtration systems could help provide fresh, clean water to billions of people. These could help control waterborne diseases in developing countries.
Other applications of nanotechnology could make our lives easier. For example, stain-proof clothing with tiny nanoscale fibers that help prevent liquids from sticking.
More wine?
Yes, please.
But with the great potential of nanotechnology, there also comes great risks. Nanoparticles are not necessarily harmless. For example, ingesting massive quantities of silver nanoparticles can permanently turn your skin blue. Scientists are working to figure out what harmful effects nanoparticles might have on our bodies, other living creatures, and the environment. So where will nanotechnology lead? No one knows for sure, but big changes are coming from the tiny world of nanotechnology.
So at the credits on this video, you can see the source of the funding. And so basically, NISENet, I'm going to introduce next. They used to be called the NanoScale Informal Science Education Network, so most everything was on NanoScale. They've changed their title in the past 2 years to encompass more things like biology and other STEM, and so I'll show you that in a minute. But NSF, they give us money, they also give money for these videos. And so these videos are available under Creative Commons, which means you can use them, you can share them, and so they are quite open and available. Any questions on the video before we go on? Okay, let's see. So let's see, I'm gonna go back here. Okay, so one of the things, the last way to relate Nano before we go on to who NISENet is that you want to relate that nanotechnology and nano are everywhere. So nano is in nature. And so you'll get these really cool pictures that you can show kids that nano is on the hairs of a gecko's feet. That's what makes it be able to climb up walls. Nano is obviously in DNA. It forms snowflakes. It makes butterfly wings turn blue. It can be in everyday fabrics like the guy's shirt or the pants that will repel water. It keeps socks from smelling if you put silver in it. That's the same silver that can turn somebody's face blue if they eat it. And it can help life by making better filters for water. So nano is everything, and it's in everyday objects. Devices are also made, and that's where we come in. This is the CNF. We make things. So this nano guitar, which is the size of a bacterium and actually has strings that work, was made here. So that's the kind of stuff we're doing. We will make nano electrodes. We will make micro gears, we will make microfluidic chips, and these chips are all smaller than an ant. And so when people come to see us for field trips, they want to hear about these sorts of things. But this is not necessarily what you would want to share if you were doing something from afar. But I wanted you guys to be aware of what we do here. Okay, so the NICE network, as I said, they changed their name a couple years ago because they changed the grant for the nano ran out. So now they're the National Informal STEM Education Network. It's pretty sweet they keep the same letters. I've never met these people, but I love these people. It's a national community of people who love to do outreach like me. They're informal educators and scientists. They get together and they make these materials and put them together in a way that anybody can go and find the materials and put together lessons. So teachers use this, parents use this, I use this all the time. So it's an online digital library of products with activities, lessons, there's electronic newsletters, they have social media feeds, and the material is appropriate from age 4 to adult, and they'll actually tell you which activity for which groups if you're curious. So topics, they have expanded from just being nanotechnology. Now, if you have kids that are meeting and they want to talk about Earth and space, engineering and technology, biology, math, physical sciences, and a lot of ethics, like food and cooking. I don't know why that's in societal topics. I guess it's not just ethics. So there are some really things we'll look at, like gummy capsules later, how gummy bears can be nano. So there are tons of topics, and if I were actually on the website, you could click on engineering, for instance, and see what all the 15 activities are that you could investigate. Okay. When this was, I'm going to give you an example of how this works, and I'm big on the nano, so back when this was just nano, they would even break it down further for you. You could get 4 key ideas for nanotechnology to make it interesting for kids. And they have examples of how nano is small and different. It explains why a gecko can seemingly defy gravity and walk up a wall and across a ceiling, and that's because of the nano hairs on its feet defy gravity. So you have different ideas that you can get across, but mostly what people want to do is just go to the web and explore and see what they like. So I'm going to take the next third of this presentation and talk about web resources, where to find all these cool, nice network things, and also where to find an electron microscope app that's awesome. and show you an example activity. Any questions before I go on? Okay. So those videos, 381 of them. Here's an example of a screenshot. This is the one we watched. You can also get many of these things in Spanish. I don't know if they have a whole lot of other channels, or I'm sorry, languages, but they have some really cool ones. So if you go to the Vimeo and simply search nicenet.org, you will come up with their page and their channel, and you can look through these. That's not the way you need to look up videos. If you wanted to do a video or a segment on butterflies, for instance, those videos are already linked on the butterfly page. So let's see. The videos, before we go on, are grouped by age. So if you want something that's appropriate for different age groups, this is how you find it, and you can click on them. And if you go to the NiceNet Network website, which we're going to go to next, you can find, for instance, that butterfly page that will have the butterfly video, it will have some handouts, it will have some pictures, and it will have a lesson. It's basically, I've got these websites at the end of my presentation so you can get the actual addresses, but this is www.nicenet.org. And this would be what the page looks like. And I'm trying to remember, I'm going to go forward for a minute. I'm trying to, where I decided to, no, and I'm not going to go to the website yet. I'm going to walk you through an example one. So if you clicked on programs and activities, for instance, and you wanted to teach your kids about gravity, there's a 5-minute activity that you could do. So if you search in gravity, you could come up with this one, and essentially a page will show you a couple images, what the thing is, the ages, it's appropriate for 4 to adult, and it will talk about, it'll give you all the downloads. It'll give you pictures, it'll give you handouts, it will give you a sign if you're doing this at a museum, for instance, and it will also give you a training video at the bottom, which is great, that you can look at beforehand and understand what needs to be done. Signs are one of the things you can print out. They come in English, they come in Spanish, so here's the Spanish version for this sign. And the idea in this video, or I'm sorry, in this activity, is that if you take a coffee cup of water, can I have your coffee cup?
Got coffee in it, though.
It's got coffee, well, and I won't dump it out. You all know what happens if I dump this cup over on my computer. It's bad. But if you take a cup that's the size that you see on your screen, that will actually, when you dump it upside down, it won't come out. And that's because when something is small, surface tension is more important than gravity. So that's the sort of thing that you're trying to get across to the kids, that Nano is small, and different, and cool. And surprising, right, Dave?
Right.
Okay. So if you click on the guide, you can print one out or you can just read it yourself. It will tell you learning objectives, if you're an educator and you want that. It will tell you what materials you need, and it will tell you where to find those really cool miniature teacups. You know, go to online and order some. And it will tell you things to do before you get started, like filling the container with water. Makes sense? They've thought of everything. Here is the guide that you can print out and hand out to the kids, and it will tell them what to do. It will tell them what's going on and why it's nano, if you're looking at the nanotechnology section, and give you some ideas. So these are pretty fun. The videos that are helpful for you as educators would be the link that has somebody at the Science Center or some other museum showing you how to work it, what it's all about. So those are always good resources. And then I highly recommend, if you're interested in doing some of this nano outreach, there's 101. So basically, brown bag talks on how to give nano talks, kind of meta. So you can also find those on NiceNet. And supply lists. So here's exactly everything that you would need if you were going to make this for a large group of kids, and where you could find everything. Okay, so what I want to do now is actually go to nicenet.org and show you an example activity. You can see how to navigate it. And it's a screen. Okay. Looks pretty good on my screen, so I think that's okay. So the nicenet.org, here you can find the activities. You can go in short activities, let's say, and say that you want to engage kids that are 7 years old or older, and you want some topics. So let's say you want to go to life sciences. You want to talk about plants, for instance. And you can see a couple of the ones here. Lotus leaf effect is a great one. That's an easy one. If you click on it, it's going to give you basically what I showed you on the screen. It's going to give you an example of what it does. A lotus leaf or an elephant ear or broccoli leaves versus lettuce leaves will do different things when water falls on them. And so it's showing you basically how this happens. Here's some kale, Ithaca's favorite plant. Letting water roll right off of it. And it will give you a poster if you want to make a poster. These are all downloads, so you'd still have to be able to print things out. It has a training video, and the lesson plan is basically the handout that you can use or you can give to the kids. Sometimes they are more in-depth, like this one. This is more for educators. And so if you actually wanted to document what you're doing, it will tell you the setup time, the cleanup time, the program time, and defines terms. So this is probably not the most user-friendly one. I just clicked on. So let's see if I can go here. But Alexa was curious about gummy capsules, so I'm going to show you how you can actually type in for a subject.
Yeah, I like the Nano ones related to food. They're really fun.
Yeah, food is a great motivator. So first off, what you see is this was linked to Nano Days 12 and 13. So this was all funded for Nano Days, but the resources are still here now. You used to be able to buy or get a kit. I don't think you can get the kits anymore, but you can still get all the electronic resources. So you can click on gummy capsules. And it says that it's available for it's good for an audience of 4-year-olds and up. It shows you all of the different areas that it applies to. And then if I open the guides, let's see, I was hoping they had one in Spanish, but they don't. Let's see here. Here's the guide. So this is what I would open if I wanted to start thinking about, do I want to do this with the kids? And it gives you the actual, or the kids, the actual thing that they would do. And so you would have to be able to find calcium chloride solution, water, obviously a strainer, and let when this calcium chloride hits when the drops hit the calcium chloride, the salt solution, they turn into these little droplets. And so it talks about what's going on. So it talks about polymers. If you read this, you can pretty much fumble your way through explaining it to somebody else. And sodium alginate, which is basically like agar, is the polymer that they use. And it talks about self-assembly. So you can talk about things that are getting into the science deep if you want, or you can not really talk about much more than self-assembly. And then why is this nano? So what they're making, the problem with nano, it's not a problem, the challenge is you can't make nano-sized drops. Kids will never see them. So what they have done is they've made you be able to make drops that are big enough for kids to see with their eyes. And then you relate it to the fact that, well, people can make drops that are even teenier and tinier, and they look like this. And you'll get like electron micrographs of these really teeny tiny polymer drops. And they're carrying little black blobs of stuff inside that's cancer medicine. And so if you want to broach the topic of cancer, then you can talk about what these might be treating, or you can say that they're carrying medicine for something else if you don't really want to talk about cancer with your group. Sometimes you can sort of change your topic, but still show that it's nano. The materials are listed here, and this is a really good website for going but you do have to put out money and buy things. And they will basically, stevespanglerscience.com will sell you the goo and the activator, which are tablets of calcium chloride, and then off you go. So think mostly the second page of the guide is usually for the educator. The first page of the guide is something for the kids to have or to hand out or take home to their folks. Okay, so now I want to go back to here. Oh, good. And there were Spanish files for this one as well. And there are links if you want to zoom into these things, and the training video. It's very handy to have. So tons of projects. I don't know, there's hundreds and hundreds of projects. We're not going to go into any more detail than that, but I do encourage you to look around and see what's there. I'm going to keep on track here. Okay, there's a Nano Days collection book. If you become a big fan of this, you can get this PDF or you can print it out for yourself. It's really big and thick, or you can, I would recommend if you're at the 4-H office, maybe printing one of these out and then flipping through it if people want to show some of these Nano projects. And so to find that, I'm going to go and search. I'm going to say Nano Days collection handbook. See if I get lucky on the first one. Thinking about it. And it's not called that. What do you think, Dave? What is it called? Nano Days collection book. There it is. So it's a digital download, so you can download it digitally, then print it out, get yourself a big ream of paper. It's about 300 to 400 pages, but it's beautiful to flip through and see everything in there. And there, obviously, there's all of the things. So even some of these really story time things that are used in libraries are listed in here and how they can be nano, like Horton Hears a Who. So tons of stuff. I was going to send everybody a CD with this, but Alexa pointed out it makes sense. You can just click on the PDF and look at it for yourself. Okay. Are there any comments or questions yet, Alexa?
Well, Nancy pointed out that she's done a similar activity before with the gummy idea. And the solution takes a while if you're going to make it yourself. So if you do decide to do that activity, you can purchase it pre-made and save yourself time, or else you just make sure you plan for the time and then you can save yourself the money.
Yeah. So those are some tips, some practical tips that may not be in these the resources that we have. And so that's good to see some people have already tried something like this. So we're not reinventing the wheel here.
Yeah.
Okay. All right, good. All right, well, let me see. Yeah, so some of these, it comes into the topic of considerations. So preparation, trying it beforehand. As Nancy points out, there are if you try it beforehand, you might find better ways to do it. And then, yeah, Carolina, that's Carolina Biological Supplies, right? That's another good source. So the considerations are, do you want to do an activity with the kids? Do you want them to, or just do a demo where they try one thing out? And then obviously the cost is how much does a solution of sodium alginate cost, or how much do butterfly wings cost? So you can sort of flip through the book. It doesn't really tell you what those considerations are. Oh, Main Street Science at Cornell. Okay. the Cornell link. Okay. Yeah, Nancy just sent a text. Yep. Okay. And you can pick things that are fun and quick and keep materials for the kids. Those seems to be the big things. If they can take something home. They have the DNA isolation experiment on that website. And I know my kids love to extract DNA from wheat germ, from strawberries, and take home a little Eppendorf tube full of DNA, and then it hangs on the door handle for the next 5 months. So there's lots of fun things that they can do that they can keep, and it's listed in that book. Okay, so the other web resource I want to point out today is one that's not linked to NiceNet, which is a shame because it's really cool. And I ran across it 2 years ago at a science communicators convention. It's called My Scope Outreach. It was created by some people in Australia, and Thermo Fisher gave them some funding, and now it's freely available on the web, and it's still here 2 years later. So I think it's here to stay. And since we work with Nano, everything that we need to look at has to use an electron microscope if we're looking at these very small things. And I happen to have an electron microscope that I wheel around and take to the science center and have kids load things up, but you guys don't have that. But what you have instead is this website. And so you can type in this web address and you come up with all sorts of activities. You can just learn about how electron microscopes work, why you need electron microscopes instead of light microscopes to see little things, for instance. And then the fun part are these activities. You can actually use an SEM, or a scanning electron microscope simulator. And they've got all sorts of things loaded in there. And so we're actually going to run this. I'm going to go back to the web because that's all you need. So we're going to Google Chrome, and it's hiding behind this one here. If I can just get it. I got it. Okay. So myscopeoutreach.org, all the basics, the activities are usually where I cut to the chase. I'm going to click on Explore with the Scanning Electron Microscope Simulator. And then it wants me to pick something. So I can do this on my laptop. I can do this on this fancy Cornell computer. I don't think I can do this on my iPad, but you have to have a computer. But what you can do is pick something. I'm not going to gross people out who hate spiders, but there are really cool pictures. What do you think, Dave? Let's go to that termite wing. That's pretty cool. Mm-hmm. So we're going to go to hydrophobic surfaces. Let's look at this termite wing and understand why it's repelling water. So I can click on it. And then what I have is instructions. I am now a microscopist, an electron microscopist. Here is my column. This is my microscope, and I have just loaded my sample in. And now I need to evacuate the chamber, get rid of the air. Then I need to select some accelerating voltage, and the kids just will mess around and figure out which voltage works best to send the beam down. The same size, I have to pick what spot size I want that beam to come down through. So I just pick one. And the Z height, how far I want that sample to be up or down. So I'm going to pick some mid-range one. And then HV means high voltage on. So when I do that, I basically turn on my electron microscope, and it shows it working. It's zapping from the filament all the way down, and the electrons are scanning across the sample. And so I would like to put this to the side, but I don't think I can. No, it won't go. And then it'll give you these little tips. Termites have wings that keep dry even in rainstorms. I'm going to get off there. And there I am looking at my termite. And so I need to obviously turn it brighter so the kids will actually be able to do all of these slides. Let's see if I can focus it. I'm trying to focus on the wing itself. And I'm not going to be very good because it's like parallel parking with somebody else in the car. It's impossible. So let's see here. Yep, I'm going to get it close. All right, so there. That's okay. That's not too bad. And then I'm going to magnify. So I'm on the lowest magnification. And then what you can do is zoom in. And so let me zoom in a little bit slower. Every time you zoom in, it will tell you something that you can see there that you couldn't see when you were zoomed out. The fracture line that allows the wings to break off when not needed anymore. The right wing has already broken away here. So I guess this is the fracture line they're talking about. So kids can see really cool things. So if I zoom in some more, that still doesn't show me why rain drops off. Let's see. Getting closer, getting closer. Ah, here we are. There's roughness to the surface that keeps the wing dry, causing water to ball up rather than spread on a layer. So all these little things are pointing out. And they actually are like your fingertips, and a ball of water will actually not be able to hit the wing, but will be trapped on the top of all of these little spikes. And so you can get rid of this and keep looking. So I know what you're going to do during lunch today. You're going to go on this website and mess around and just try things out. It's free access, and you can look at all sorts of cool things. Okay, and typically what I do when I have kids come and do this at Cornell, I have a little half sheet of paper that has the web address and the front page so that they can take it home and try it at home. All right, any comments on that, Dave? No, I'm looking at comments. Dave gave me the little comment thing. Okay, good. So we're rounding the corner here in this presentation. Okay, so that is my scope outreach. And the final third of this lecture or webinar is going to be about what we have here at CNF. So I have to admit that I get all my stuff from what we just looked at, from the web resources. The only other thing I really do here is that I can give kids FaceTime tours of our clean room. So they can call in through FaceTime. I give one of the fun staff members tell them to call on their cell phone, and then they show how they dress up to get in the lab and how they, and then they go ask a scientist a question. They go bug the people that are actually working in the lab. We also have Nanos, I should say that one. These are magazines. So I guess I do have two things. I have the FaceTime tours and then I have Nanos. Nanos is a channel. It's got a website, and it's also a kids magazine that is produced in part through Cornell. It comes in English, Spanish, and Portuguese. And if this website, you can actually download PDFs of each of these Nanoses, or you can write to us and we will send you copies. We send copies to school classes across the country all the time. And so that's what NSF pays us to do, is to print these out and send them. So Nanewsletters, I don't know, I think we're up to about 19 issues so far. So for instance, you have ones on the environment. They're about 10 pages, and they're very colorful, very glossy magazine, and they come in different issue topics. Environment, energy. There's a really great one on food. I think there's a series of 3 on food, and they feature kids and doing things, and they're actually very understandable for parents as well. So they're very good. The website, you can also click and listen to interviews on nanoscientists, some of them here at Cornell that have done these sorts of things. So my interaction with the kids is to have them come to Cornell sometimes. And our clean room, you can't go in there unless you're 19 or over, because there's some pretty nasty chemicals in there. So this is where we've come up with this idea of FaceTime tours. So you could have, in theory, one of your troops call us during Monday through Friday when we're working, which is 9 to 5, and we would actually walk through and give you a tour. And so this is me in front of different kids. I'm holding the iPad, which is hooked up to a speaker or a large television. But essentially, the guy that you see in the screen is a staff member, and he starts off in the clean room in regular clothes. He shows them how to dress up and why he dresses up, and then he walks into the clean room facility and asks people, hey, what are you doing on this machine? Oh, you're coating stuff with gold. That's cool. Or what are you looking at in the SEM? And they'll show actual things. Oh, okay. I'll get to that in a minute. So the kids will also do hands-on stuff. So we'll have people, especially in the summertime, groups will come and we'll go outside and we'll investigate the sun energy and how we can use it to make film patterns. We have kids that will load, this kid is loading he's a 6th grader who came in a field trip, and he's loading a sample into our electron microscope. So we let the kids actually use the tools. We let them dress up. Here's my son in a clean room suit, standing in front of a picture of a tool. And we will have microscopes, lots of hand microscopes, electron microscopes, that kids can look at things and get the idea that there's a different scale of size. All right. Here's, if people want to come to Cornell, typically we get them in groups of 20 or less. One of these example would be the career explorations for 4-H that Alexa coordinates in the summer. And we will have them come through and we'll show them, here I am holding the meter stick. So obviously I'm talking about nanometers. And then we can't take them in the clean room. We'll give them that, the FaceTime tour. And we might even send some work that they've made into the clean room to be developed. and worked on, and then come back out and they finish it up. So what they're doing here is they're actually testing their little computer chips that they made in the clean room. So they made a design, they sent it to the clean room, we turned it into a little electrode circuit and sent it back out for them to test using these multimeters. So they learn a little bit about physics as well and electronics. Here is the 4-H chips that we've made the past couple of years. The idea, I think this is this year's one. So so there's a little 4-H clover. These lines that you see are copper, so they actually conduct. They're on a piece of plastic, basically computer control circuit board. And there are lights, LED lights. So if they've made this right, you can put the battery to the contacts and actually get them to light up. You can also use multimeters, and we have staff show them what a multimeter measures, and they can actually measure the conductance across circuits. And part of what they're doing is making patterns with light. And so in the summer, there's enough light outside that we can actually transfer these patterns just by using the sun's energy. And we talk about fancy stuff called photolithography, which is writing with light. And that's what actually makes these patterns here. So I think that's most what I have. There are the websites listed here, so if you get this saved, you can write down them. There's Cornell websites and how to catch us, how to understand how we can do a video tour. This is the Nano's site where you can order Nano's catalogs, or you can just read them and download them as PDFs. NiceNet is gold, so these are the ones you definitely want to go to NiceNet. Here is that Nano Days collection book. And here is the Vimeo with a collection of all of their videos. And then this really fun electron microscope outreach. Basically, it's the simulator, and it's really fun to use as well. So, oh good, and Alexa's typing them out. Thank you very much, Alexa. So I'm gonna look at the chats, and I see there was one chat while I was talking about the SEM from Nancy. And the question is, or the comment was, if kids have an insect to inspect, they can send it to BugScope at the U of Illinois at Champaign, and they make an appointment and go live to watch their insect next to them. That is cool. That is totally cool. And then, oh, and so you also got to do the FaceTime tour during the UU CareerX. So yes.